In this video of booster compressor maintenance and operation series, we will be reviewing the booster compressor operation.
Proper operation of the booster compressor is essential to ensuring safe, reliable, and efficient oxygen delivery. Operators must understand the controls, indicators, operating modes, and safety precautions as outlined in the manufacturer's operating manual. This knowledge enables operators to respond quickly to system conditions, maintain equipment integrity, and protect personnel. Before turning on the booster compressor, 4 prerequisites must be met. First, ensure the PSA plant is running. Then, wait for the system to reach purity, which is typically 93 plus or minus 3%. Next, confirm that the oxygen tank has reached sufficient pressure. The oxygen tank has reached sufficient pressure when its pressure display gauge shows a pressure higher than the minimum inlet pressure for the booster. Finally, verify that empty cylinders are connected to the filling manifold. Waiting for the system to reach sufficient purity is critical because the booster does not have its own oxygen purity sensors. The booster compressor only checks for sufficient pressure. If the oxygen meets the pressure requirements, the booster will fill cylinders, even if the oxygen purity is low. Once all 4 prerequisites have been met, the booster compressor can be safely switched on. The control panel displays essential system information and operational controls. These include the operating mode dial to turn the machine on and off, the emergency stop button to instantly shut down the machine, temperature level readings for each stage, pressure level readings for each stage, the current running hours of the machine, and all system alerts. Note that control panels from different manufacturers include different features. Familiarity with the control panel layout and functions is important for safe and efficient operation. Indicator lights help technicians quickly assess system status and identify fault conditions. Each model uses a different indicator system. Always refer to your booster compressor's manual for full details. For the RIX 2V3B, there are only 2 indicator colors. Green indicates the system is on and running, while red indicates a fault. The Bylon GOW15 uses 3 colors. Green means the system is on, yellow indicates the machine is actively running, and red signals a fault. On the Bylon GOW20, however, there is no red light. Instead, there are 2 yellow indicator lights which correspond to a specific fault: low inlet pressure or high temperature. Green still indicates the system is on and running. Understanding these indicators is crucial for quick diagnostics and effective troubleshooting. Check the manual for your booster compressor to understand the indicator lights for your system. There are typically 3 operating modes on all booster compressors. In off or stop mode, the booster is not running. In the 2 running modes, the compressor will automatically enter off or stop mode if there is insufficient oxygen input or the target pressure for the oxygen cylinders is reached. In auto or remote mode, the booster controls itself using the inlet and outlet pressure sensors to cycle on and off safely and efficiently. This is the recommended mode as the system will restart automatically whenever the system requirements are met. In hand or spot mode, the operator must manually press start each time after the booster cycles off. Operators must make this decision based on current system demand, available oxygen supply, equipment readiness, and safety conditions. This is the recommended mode while troubleshooting and testing. There are 2 pressure switches that control the booster compressor. The inlet switch turns the booster off if the incoming pressure falls too low, while the outlet switch turns the booster off when the target pressure for the filled cylinders is reached. It is normal for the pressure switches to cycle the booster compressor on and off to maintain correct pressure while in auto or remote mode. The high pressure switch will turn off above 150 bar and resume below 130 bar, while the low pressure switch will turn off below 2 bar and resume above 2.25 bar. Note that if the booster compressor loses power when cylinders are filled between 130 and 150 bar, the booster compressor will not automatically turn itself back on. Booster compressors come equipped with temperature sensors to provide real-time temperature readings. In many models, these sensors come before and after each compression stage. In other models, there may be only one temperature sensor. These sensors help ensure the compressor operates within safe limits and allow operators to identify any irregularities early. Alarms are triggered and the booster compressor automatically stops if temperatures exceed 140 degrees Celsius. Note that not all booster compressors have temperature displays. Booster compressors are oxygen-rich. The high levels of oxygen increase the risk of fire drastically. The fire triangle illustrates the 3 essential elements required for a fire to start: oxygen, heat, and fuel. When oxygen levels are higher than normal, it takes less heat and less fuel to start a fire, and, once started, the fire will be more intense. This means that around the booster compressor, we must control heat sources and eliminate potential fuels, such as oil, grease, or combustible materials. Mechanical hazards are also present around the booster compressor, including risks that may lead to burns, hearing loss, or injury from the sudden release of pressurized gas. To mitigate these hazards, operators must wear appropriate PPE, such as hearing protection and safety glasses. Fully depressurize the system before performing any service. Allow hot components to cool before contact, and verify that oil and coolant levels are within specifications before startup. As the PSA plant operator, it is your responsibility to safely operate the booster compressor. Understand the operating modes and the safety hazards associated with running your booster compressor. Monitor the key indicators for the booster compressor and record those values in your plant's daily checklist. By following proper operating procedures, you ensure your booster compressor functions safely and efficiently, allowing for reliable cylinder filling operations to support your health system.
We hope that you have enjoyed this introduction to booster compressor operation. Continue on to learn more about booster compressor maintenance schedules.